circuit analysis. Today's topic is about mesh analysis. So we are going to deal mesh analysis problems. So already we know about what is mesh. So two or more loops in a circuit is known as mesh. It is mainly used to determine the current flowing across the circuits. So here this mesh analysis problem consists of two loops. So consider these loop as loop 1 and this as loop 2. So this loop 1 is identified as I1 and loop 2 is identified as I2. So here we are having a voltage source of 10 volt in loop 1 and there is no voltage source across second loop. So firstly we have to apply KVL. So KVL is the Kirchhoff's voltage law. We already know that voltage across any closed loop is equal to 0. So we are equating that for the loop 1. So here 10 volt minus current flowing across the sources considered as fall in potential and rise in potential. So fall in potential is the loop travels between positive to negative is known as fall in potential. Negative source to positive source is known as rise in potential. So here consider this loop 1. So apply KVL at loop 1. At first loop we have 10 volt minus this is entering node, so that minus 5 I1 and then we have to consider these resistor. This resistor is 5. This is common for I1 and I2. With respect to I1, we are writing this 5 ohm resistor as I1 minus I2 is equal to 0. So here 10 is equal to 5 I1 minus 5 I1 plus 5 I2 is equal to so here we are equating this 10. So that we consider here 5 I1 plus 5 I1 is equal to 10 I1 plus 5 I2. This is considered as equation number 1. So as like that we have to solve for second loop also. So apply KVL at loop 2. So what we get is 0. So apply KVL at loop 2. So here we don't have any voltage sources, so that we directly consider the resistance. So I2 is minus 5 I2 minus I1. Why? Because this 5 ohm resistor is flowing across loop 1 and loop 2. So that I2 minus I1 and then this 10 I2. So here 0 is equal to minus 5 I2 plus 5 I1 minus 10 I2. So we rewriting I1 I2. So 5 I1 minus 15 I2. This is considered as equation number 2. So that we have to reduce the following equation. So here in first equation we have to reduce it as 2 is equal to 2 I1 minus I2. And then here I1 minus 3 I2. So apply Cramer's rule to determine the del 1, del 2, del 3 values so that we can get I1, I2, I3 values. So here we rewrite this as voltage, resistance, so here I1, I2 is equal to the resistance value is 2 minus 1, 1 minus 3 is equal to voltage is 2 and 0. So here for this value we have to apply the Cramer's rule. 2 minus 1, 1 minus 3 is equal to, we can get del value. So here 2 del value, we have to find out del 1 and del 2 value. Why? Because this mesh analysis problem consists of two loops, so that we can find out del 1 and del 2. So here, for del 1, we have to rewrite these value, voltage value in the first values. So we can get 2, 0 and then minus 1, minus 3. So for applying this Cramer's rule, we can get 6, 0. So del 1 is equal to minus 6. So like that we have to apply del 2. So here 2, 1 and the voltage value is 2 and 0. So for del 2 is minus 2. So after finding out these del 1, del 2 and del value, we have to find out I1 and I2 value. So for applying Cramer's rule, I1 is equal to del 1 divided by del 2. For I2 also, del 2 divided by del is equal to I1. We have to find out I1. Del 1 is minus 6. We already know that del value is minus 5. For I2 value, del 2 is minus 2 and del is minus 5. So calculating this, we will value. So for I1, we can get. So for I1, we can solve this equation and then get 1.2, and for I2, we can get 0.4. So in terms of current, we have to mention it as amps. So by applying KVL for each node, each loops, we can identify del value, del 1 value and del 2 value, and then we have to find out I1, I2 using Cramer's rule. We can get the I1 current and I2 current as well. So the current across the loop, flowing through the loop, across this loop I1 is, and we have to find out this I2 equal to 0.4 and 1.2. This is how we can solve the two loops mesh analysis problem. Thank you.